Hi guys, welcome to my session on energy of electron. My session on energy of electron. This is a continuation of Bohr's theory only. In this, a mathematical expression we are going to derive for energy using making use of the radius of that orbit, electron orbit. Radius also we will use. In the previous session we have discussed about the radius as well as how its derived formula is coming in the Bohr's concept. In that, a few points we will consider before finding this energy of the electron. One is the radius value r is equals to what we have derived is n square h square by 4 pi square me square z into k. 4 pi square me square into z into k. Another one, there we have discussed about one concept of the force of attraction called as Coulombic force of attraction between this nucleus and electron, which is equals to k into z e square by r square is equals to the centrifugal force mv square by r. It means there we have obtained mv square answer is equals to k into z square by r as mv square by r. This is one point should be remembered. This another one point should be remembered. At the same time, we came to know that there is a potential energy of this one when the electron and the nucleus are separated by their distance r, that is minus k into z e square by r, considered as potential energy of the electron. So by virtue of motion, kinetic energy, by virtue of the position, that is potential energy. So from this me square answer, the kinetic energy also can be given as kinetic energy is equals to half mv square will become equals to k into z e square by 2r. So we will make use of all these expressions to derive what is the energy of the electron. Let us talk about the energy of the electron. The total energy of the electron can be obtained by summing this kinetic energy and potential energy of this electron in the orbit. So if you substitute these values, kinetic energy is k into z e square by 2r, whereas potential energy is minus k into z e square by r. So here plus will become minus because of potential energy is minus. So in this, if you take this common values, then it will become k into z e square by r is common, and after that it will become 1 by 2 minus 1. So 1 by 2 minus 1 is minus 1 by 2. So it will become k into z e square by 2r. K into z e square by 2r. So what is the energy of the electron? Total energy of the electron became minus k into z e square by 2r. But we know that what is exactly the radius of this electron orbit is this one, this r, this expression if you keep here, then we will get minus k into z e square by 2 into what is this, n square into h square divided by, means it will come to the numerator, it is 4 pi square me square into z into k. So if you little bit simplify this one, 2 2s are 4, so I will write minus 2 into, this is pi square, this m into e square is e power 4, z into z square, k into k square divided by n square h square. So this we will call it as total energy of the electron in the nth orbit given by Bohr's theory. So observe the formula, minus 2 pi square m e power 4 into z square into k square by n square H square. This is the expression for energy of the electron from Bohr's mathematical ideas. Let us see. In this, if you substitute all these values like pi, m, e, k and h values in this formula, we will get the energy of that nth orbit of Bohr's concept is minus 2.18 into 10 to the power of minus 18 18 joule per atom by n square into z square. Here into z square I will write. Okay, this joule per atom answer. If this you want to write in electron volts per atom, it will be minus 13.6 by n square into z square will come for this nth orbit. This is electron volts per atom will come. Whereas you just want to give this answer in kilojoules per mole or kilocalories per mole. Kilojoules per mole if you want to give, it will be minus 312 or 313 by n square into z square, that is kilocalories per mole. Kilojoules per mole. This is kilojoules per mole. Whereas kilocalories you want me divide this one with 4.18, you will get 313.6 by n square into z square. This answer will be in kilocalories per mole. So these are the values you will get after substituting this pi, m, e and k and h values in this Bohr's energy expression.